You have somewhat of an idea of what dating techniques are. Commonly seen in movies about dinosaurs or really anything old, there's a scientist who does their science techniques and gets some sort of estimate for how old some bones or fossils are. But what do we use fossils for in real life, and what techniques do we use to date them? One of the main goals of anthropologists, archaeologists, and the like is to reconstruct the lives of humans in the past. Anthropologists examine all kinds of remains, most prominently bones and teeth. These items can help anthropologists understand the physical traits, health status, and diet of ancient humans, which can help us to recreate how they lived and learn more about them. One of the most important things to understand before we really get into the specifics of dating is what fossils really are. Fossils fundamentally are remains or traces of animals and plants that formerly lived on Earth. This includes bones, but may also include other items like coprolites, or otherwise known as ancient poop. For something to become a fossil, they first need to be buried. This burial can happen in many ways, whether it is getting covered in sand or gravel from sandstorms, or being submerged by mud in a swamp. Being buried protects the carcass from the outside elements and from other animals. Since the carcass is being protected through burial, it has a higher chance of being preserved for many years. Now that we know how fossils are formed, we can begin to talk about dating techniques. Dating techniques have two major categories: absolute techniques, which use laws of nature to give numerical estimates of age, and relative techniques, which use comparative analyses to compare the relative ages of several objects. To start, we'll look at radiocarbon dating, a type of dating that can be done on organic matter such as bones. The idea of radiocarbon dating is based on the carbon life cycle. In the upper atmosphere, nitrogen atoms fuse with lone neutrons producing carbon-14, a radioactive form of carbon. This carbon then forms carbon dioxide, which is absorbed by plants through photosynthesis, and by animals through breathing, leaving these C14 molecules trapped within them. Since this CO2 is trapped, when the animals die, there will be a certain ratio of radioactive CO2 to regular CO2 within them. Since this quantity can no longer change, we can compare the ratio of CO2s within fossils to a database of ratios over time to determine their age. Of course, nowadays we have advanced machines to measure those ratios, but how can we know these ratios from times before there were radiometric measurements? Well, we must look to an old friend, trees. By measuring the carbon incorporated into tree rings, we can get a somewhat continuous record of radiocarbon in the atmosphere for different regions. This allows us to form a carbon timeline way past the era when we had complex machinery. This field of looking at tree rings is also referred to as dendrochronology. Dendrochronology works on the fact that trees in similar areas all experience the same carbon ratios within their rings over the same period of time, meaning that this common ring pattern is shared between all wooden things made from wood at that time, like tools and buildings, so you can figure out how old certain wooden items are. The final thing to note is half-life. Since carbon-14 is radioactive, it experiences a reaction called radioactive decay. Simply, it has a 50% chance to decay into nitrogen after one period of its half-life, about 5,700 years. So, we can expect that if we have 100 carbon atoms initially, after about 5,700 years, 50 atoms should remain. Since we expect this ratio of carbon-14 to regular carbon to drop off at this exponential rate independently of any other factors, this makes radiocarbon dating a great technique for dating fossils, since there will be only one changing factor, time. Then we can trace that backwards to find the original ratio of carbons and therefore determine the age of the object. Potassium-argon dating is a different form of dating that can be used for rocks. Potassium stored within rocks can sometimes perform a reaction called electron capture, turning the potassium into an extremely stable argon gas. This form of dating works on the principle that argon is an inert gas that does not react chemically, so after a rock is formed, there should be no argon within it. So slowly, as the potassium within rocks perform electron capture, occurring similarly to radioactive decay, but now with a half-life of 1.25 billion years, we can use this measurement to determine the age of rocks. Since this half-life is so long, we can even date rocks formed billions of years in the past, including extraterrestrial objects like meteors. So now that we know our absolute dating techniques, we can talk about how they can be applied in anthropological practice to date other objects relatively. These techniques are extremely prevalent in the act of site digging. Basically, after it is determined that a site will provide enough important data that it should be dug up, anthropologists and scientists will work together to dig it up. One of the main principles of site digging is the idea of strata. Basically, over time, dirt will form many different layers, which may be visually different but might not be. This leads to one of the most important ideas in all of archaeology, the law of superposition. Simply, it is the idea that physics works everywhere always in the same way. We can assume that when the ground is undisturbed and the dirt layers slowly pile up, the oldest layers are on the bottom. This means that any artifacts or items dug up at the bottommost layer, given the sequence is undisturbed, will be the oldest. A lot of the time, it is difficult to use any sort of absolute dating technique. There may be other factors at play making it impossible to use them, like if the artifact is too small or too broken to get a good sample. However, if two artifacts lie in the same strata, and you can date one but not the other, you now have a great estimate of the age of the other object. That is, if you can perform an absolute dating technique on one object, whether it be radiocarbon, potassium argon, or dendrochronological dating, other items in that strata must be closely related on an anthropological timescale. If we can date one object that is physically above another, then we know that the other object must be older. That is one of the beauties of these dating techniques. We can date things that we have no information whatsoever about if we just utilize the laws of physics and a little bit of logic. Isn't that awesome?